Yes, so then again, the class of today is on rapid descriptive sensory methods. We also can call them alternative descriptive sensory methods, because we will see that all of them are quite rapid from the consumer perspective, but not always from the researcher perspective. So what we will learn today, we will learn about diverse alternative descriptive methods in sensory science, different types of rapid or alternative methods, so how to do it, for what objectives, and when or when to apply one or the other. You will see that many of them can be applied in the same occasions, so it could be other parameters of choice in this case. So a bit of reminder of things that we have already mentioned in multiple classes, that in sensory science we have analytic sensory methods, usually with trained panels that look into discrimination or description of samples, and we use subjects to detect and to measure. And we have other group of methods that are the affective methods, consumer tests, where we ask for example, liking, preferences, qualitative tests, etc. And there's usually this line dividing these two types of tests in sensory science. However, when one thinks about this is classic sensory science, and in the last years there were these tests developed where this line became a bit blurred, and we will talk a bit more about that. So when we think about descriptive sensory analysis, for example QDA, that we saw a couple of classes on that, or other methods like spectrum that we mentioned in the descriptive class lecture, and they are very time consuming because you need to recruit, you need to train assessors and train for specific products, so they are not really adapted for fast track projects. Also, this type of method needs product-specific training. So it's not only trained on the method itself, but trained on the actual attributes and specific products. That could be a problem for small companies that don't have panels, but also a problem for big companies that are multi-category companies, that maybe they have a panel, but the panel is not really trained in all the categories. And sometimes it's also difficult to get table references for training. Think about if you are working with fruits and vegetables. Fruits and vegetables, when they are raw, they are changing all the time, and it's many times very difficult to get references that will show the whole range of attributes. And more importantly, classical sensory profiling methods like QDA assume that the perception is the same for consumers and for trained panelists, so that the analytic versus holistic experience is the same. And that is not always the case, because what a consumer perceives is not a collection of separated attributes, but it's a whole, the product as a whole. And unless there is something wrong with the products, they don't think about the sweetness level or about the masticability or about the consistency. They think about how much they like it, and maybe if they are surprised with something, they will think about a specific attribute, but generally speaking, they don't. While a trained panel is looking into very detailed attributes, so it's really a very precise instrument when we work with a trained panel that we can at the end correlate with the consumer experience, but they don't represent the same experience. And I think I showed you in a previous class this schematic view, or a more simplified one. I'm not expecting that you read all the bubbles, but it's a food choice model that I like a lot from Koster and Moyet, that it shows different aspects of consumer perception. What you see, this is product parameters related to food choice, so intrinsic product characteristics like the sensory characteristics and also composition and so on. Extrinsic product characteristics like could be the pack, claims on the pack, etc. But also a number of consumer parameters that are related to food choice, like how are we feeling, if we are stressed, our nutritional needs, so the situational factors, like could be if we are eating alone or in company, our culture. So many things are really defining how we choose food. But sensory is only this bubble here in this world of parameters that underlie food choice. Of course, that doesn't mean that sensory is not important. It's very important because it has to be right so the consumer chooses the product again. But we need to realize that there is, of course, much more than sensory in food choice. So can we reflect that through using other methods with consumers? So these novel methods for product profiling or for product description, they are generally called rapid methods because initially were designed to reducing timings. Also, they are quite useful because they can be used with with panels of the different degrees of training, like trained, semi-trained, or even consumers. And if we use them with consumers, they may take into account other parameters than only the sensory perception. So they can take into account hedonics, usages, attitudes. We will see some examples. And some of the methods use holistic approaches, like the projective mapping methods you tried today, that are closer to the real choice experience. So for example, today when you were trying to move in the map these crisp samples, you weren't thinking of saltiness or on crispiness specifically, but you were thinking onto many characteristics at the same time. And that is really what happens when consumers are choosing. So then this classic line between sensory and consumer science becomes a bit blurred because it's not only that we can have a very much trained panel to describe a product and only asking how much they like the product to a consumer. It's also interesting for many objectives to get consumers' description of the products. And that could be quite complete into many aspects further than the sensory. So these methods, until some years, they were called novel methods of consumer profiling, because during many years, sensory science was trying to standardize product description, but then many new techniques appeared, and there are many research works that you can find in literature since, for example, the 2000s. So already some of them, they have 20 years. Some of them are newer, but most of them, they have been researched quite a lot. So we know that they are very valid and reliable. So there are different methods we can use. Two of them you have tried today, and we will describe more. We will talk about some others. And they are based on 4 different perspectives. Some of them are based on the evaluation of global similarities and differences, what we call more holistic approaches, like projective mapping that you performed today, also known as napping in some literature. Sorting, it's another method that will be, in a way, a simplified projective mapping, because it's not that you try to map product, but only to sort into groups. Then there are other techniques based on the evaluation of specific attributes, like check all that apply, or CATA, the one that you used today. Another one based on attributes is flash profiling. Other methods are based on the comparison with references. For example, polarized sensory positioning. There is a new one that is called pivot profiling. I didn't include it on the slides. And there are other based on pre-description. So for example, we can use open questions for generating product description. We will focus today only on those ones that are highlighted on the slide: projective mapping, flash profiling, CATA, PSP. And yes, because we have only 1 hour and this could be covered in a longer course. Of course, within InnoFoodAfrica project, this could be an area that we could go much deeper in future courses. Today you tried a bit the tests. We will see some of the theory, but we won't go into, for example, data analysis. And this it could be very well the topic of a future course. So please stop me at any time, because I see I'm seeing if you're raising hands or just put on your microphone if you have a hot question, a burning question. Otherwise, we can also take questions at the end. So we start with check all that apply that you tried earlier today. We said this method is based on the evaluation of individual attributes where consumers or assessors select as many options as they consider apply to the sample they have tasted, or in your case, looked at. So in fact, it's multiple choices questions where assessors get a list of pre-selected attributes to choose from, and they can check as many as they apply. So that reflects the name, check all that apply. This kind of method is a very old method, for example, in marketing, where they have used this for surveys for many years. But it's been brought into sensory science in the early 2000s, where we use it also to describe sensory attributes. So as you see in the example on screen, that is an example of a CATA question for yogurt. You see for this yogurt, different attributes were selected, some of them covering sensory aspects like very sweet, creamy, tasty, very sour, or there are other attributes that are non-sensory like satiating or natural, or usage attributes like for children or to eat as dessert, or some related even to more attitudes related to healthiness. So it can cover more all those aspects we have talked before of reasons or parameters underlying food choices. So I said at the beginning of the lecture that this method can be utilized with panels of different degree of training. I will be highlighting mainly or mostly the consumer side of it, because we can use it for consumers, but we can also use them with semi-trained panelists. So then you see that we need for this a list of attributes. Where do we get this list of attributes from? It could come, for example, from previous info from the product. If we have a sensory base, if we have previous data from a sensory panel, we can use those attributes and simplify them or translate them to consumer vocabulary. It can come from consumer tests, for example, focus groups, or tests like free listing or word association that we do in some of the samples to develop a questionnaire. Or also it could be attributes or concepts of industrial particular interest that, for example, either the client, or if we are working for someone, or other areas of the research team are interested in. As I was mentioning before, it could be health, it could be usage, attitudes, so many different type of attributes that can be included in this list. So CATA is a very simple test, but also very informative, as we will see. Here it's another example of a ballot on bread, where we have a group of sensory attributes and group of non-sensory attributes, like hedonic, usage, attitudes, some marketing relevant. So you can add something like yummy, for example, if you are using this method with consumers. So here I present an example of a paper already from 2011, where we compared different consumer profiling methodologies. One of them was CATA, and We applied it in some powdered orange drinks. I think in different countries in Africa, these orange drinks or powdered orange drinks like Tang are very common. In Europe, they are not so common, so maybe the people living in Europe attending the course, maybe they don't know, but they are kind of a powder product that you dilute in water to make a drink. In this case, we had 7 different samples, and consumers, apart from the 7 real samples that they tasted, they also assessed one ideal sample. We used 50 consumers on one session. And here you have the table of the attributes that consumers assessed for the 7 orange powder drinks. So for example, very sweet, sweet, not very sweet, bitter, others like yummy, disgusting, natural, intense in flavor. So we have here the 7 real products, and last column is the ideal product. So already we can see very clearly what were the real samples, or what consumers would like to have in their ideal sample. So remember, there were 50 consumers, almost all of them selected sweet, some or more than half dark color, yummy, of course, orange flavor, natural, and soft. And we can see what are the real products that are closer to them. For example, sample 5, it was quite selected as sweet for many consumers, dark, yummy. So it was closer to the ideal into some of the parameters, not so much on orange flavor or natural. Very few consumers, as you see, selected natural for the real products, of course, because these are not natural as per characteristics. So even if everyone would like to have a natural orange juice, it's a powder juice, so it's very difficult to obtain. And we can also see which of the real samples was farther away from a sensory perspective from the ideal in consumer's mind. So you see directly that only looking, sorry, I will take sweet because you can see I'm struggling with the throat. So to see if I'm better. So as you can see, very easy, just with the frequencies of mention of the different attributes for the different real products, we are comparing with the ideal evaluation. We can see very easily which products are closer to the ideal. If these were 7 prototypes that we were comparing to launch in the market, we could easily use this information to select what are the best products. As we did in the test that you ran online before we started with the lecture, we can obtain some maps like the ones we obtain via principal components analysis in QDI, but in this case, as it is frequency data, multiple correspondence analysis or multiple factor analysis can be utilized. As I said, maybe in a future course, we can look a bit more into the statistics part of it. But you see, we obtain a product map. Here is the ideal setting. Here are, for example, products 3 and 5 that were closer to the ideal. We saw that product 4 was very far away from the ideal. And I hope you still hear me. We see also the attributes that were associated to that. So we see that the ideal was linked to orange flavor, yummy, intense flavor, natural, and products 3 and 5 are close to this area, sweet, dark in color. So important considerations in CATA questions are what is the number of attributes we should use, the type of attributes, and the order in the ballot. The number of attributes, of course, there is no rule set on stone because it would depend on many factors, like if the samples are more complex or less complex. If it's something that is a liquid, like the juices we were talking about, maybe we can have a lot of attributes. But if the samples are more close, more complex, imagine you have a pizza, so you need to balance it out a bit because it would be more saturating, or if you're assessing chocolate, that is more saturating. So there should be a balance also number of products you present and number of attributes you ask consumers to check. It's very easy, but if they need to read a lot of attributes and taste and retaste to assess them, could still be tiring. Also the type of attributes, of course, if you ask about some non-sensory attributes, those are easier to assess. So then this is more about thinking than tasting, but you shouldn't ask too many sensory attributes. And we will see that the order in which you assess those attributes will be also important. I think in the session you tried here today, the attributes kept rotating, so they were balanced following a design in the session. And this is because we as human beings, we tend to simplify our assessment and our interpretation of things and try to simplify the task we have at hand. So in this case, it's a very interesting work, but the group of Gastonares, that they looked at different CATA tests, and they use an eye tracker to see how consumers read the CATA ballot when they were doing the test. And what I will look at the question straight away. And when you are advancing in the test, what they could see if they didn't rotate the attributes, people will tend to read more the attributes that are in the top left, because we read like that from left to right and from top to bottom. So once you get accustomed to the attributes, your eyes goes always to the first one there, but then the others will get less reads. And if you see the ones at the bottom, so red means more people looking at it, and green, less people. So then it's important to rotate the presentations of the attributes, so you make consumers read them. So attributes need to be randomized across assessors and products. I will read this question by Karina. Would CATA tests done on individual attributes be more accurate as opposed to including all sensory attributes? I don't understand very much the question, Karina. If you want to put your microphone on and explain a bit more, because I don't understand the difference on individual attributes as opposed to all sensory attributes. Do you want to put on your microphone, Karina, and explain a bit more the question? For example, words used to describe the appearance used in one CATA test. I don't know if you are talking about the grouping, or because I here have, maybe you can group by modality, like appearance, flavor. Are you talking about the rotation? Because one recommendation is, for example, that you rotate the attributes, but you keep all the appearance one together, then the smell, then the flavor, and so on. So it's not so confusing for the consumer. Okay, yeah, so it was about the rotation. If you randomize every attribute, it's a bit confusing for a consumer, because suddenly you ask about the texture, or you ask about, so then you can keep groups of attributes while you rotate them among them. Also type of terms like sensory use, emotions, and so on. So you can have like blocks of attributes that you rotate among them. Yeah, good, Karina, thank you. And so this is an example. If you see here this ballot that is for a bread, take all the attributes that describe your ideal bread. So here you have sensory attributes, and here you have non-sensory attributes that are separated. So then you can rotate among them. I see that in this example, all the sensory seem to be rotated, but it would be a good idea to have, for example, one group that is the appearance, one group that is the flavor, and so on. And this is an example also of a combination of CATA question with the assessment of overall liking. So this will be quite typical for a consumer test in which you have the question, how much do you like this bread? And then a CATA test. And in this case also the assessment of an ideal bread. So consumers will be the same thing for all the real samples, and then at the end for the ideal. And this assessment of an ideal sample, as we were saying before, can help us to see where the preferred sample is. So an area of a maximized preference for consumers. So it will be quite similar to a preference mapping in a way. So this is an example of different fruit fillings, where here are different samples that were formulated with different thickeners, and it was used CATA to measure a number of attributes that were sensory and non-sensory, and at the end their ideal sample. So we can see that the ideal sample is sitting here in the map. Also overall liking was measured, and of course overall liking is maximized towards the ideal sample. And we see what are the attributes that were driving liking, like for example soft, consistent, sweet, delicious, fruity, and all the usage attributes that were linked to that. So you see, it's a very easy test, but gives quite a lot of information on the samples. So what are the applications of CATA questions? They can be done with trained or semi-trained panels, but they are most adequate for consumers because they are very simple. We can add them very easily to a liking test and get all this extra information about the samples to be combined with the liking data. We can get a description of the samples by consumers through a very easy task for obtaining a sensory description, but together with other parameters like usage or attitudes linked to the samples. It's easy for researchers to add it, for example, to an acceptability test, and then it can be linked to consumer liking or acceptability. And this use of an ideal product evaluation for identified preference areas, it's also very useful to see what are the attributes that are expected in the ideal and they are not in the samples, or vice versa. Maybe you can identify attributes that are not wished in the ideal. There is much more complex analysis that one could do on this data. Maybe some of you know about them. That is called penalty analysis and gives much more information about this comparison with the ideal sample. So CATA is a very, very useful method. So any more questions about CATA before we jump to flash profiling? As I said, for example, there are papers that have used CATA with semi-trained panels. With trained panels, unless they don't have any training, I would say that it's not that useful to use CATA with a trained panel, because trained panelists can use, for example, intensity scales or other measurements of intensity of the attributes that could be very interesting to have. So CATA is more used for either semi-trained panels or mainly consumers. Also, because being only selection of terms, we need to have a good number of consumers, so we obtain a map that makes sense. Okay, I don't see any question on the chat. So we continue with flash profiling. Flash profiling, from the classification I mentioned earlier on, it's a method that is based also on individual attributes, similarly to CATA, and it's the one that is, let's say, more similar to QDA. So it was also developed in the early 2000s, and it's a mixture of free choice profiling and ranking of samples. So free choice profiling, maybe of you have heard about, is in a way similar to QDA, but where panelists assess the attributes they decide. So it's a free choice of the attributes. So in flash profiling, samples are evaluated all together. So it's a comparative method, and they are evaluated in 2 steps. The first step is the development of the attribute. That's individual for each panelist, and the comparative evaluation and ranking on each attribute where ties are allowed. So in the first step, we will give all samples together for comparison to a panelist, and we'll ask them to compare them and come up with a list of attributes that will represent the differences among the samples. So for example, this person is evaluating a yogurt. And
do you mind, I see a question from Karina, or you respond to it at the end of, it's on CATA.
Okay, yeah. So if I'm applying CATA, what do I need? Like a program in a computer where consumers input the feedback. So we can use a program like the one that we used in the test you did at the beginning of the class today. So using a data collection software that could be iQuestion or could be this kind of Google Forms, because these multiple choice questions are in also in the free softwares. But you can do also on paper, because you can print the ballots and people can write and then you input the data. So it can also be run on paper. And all the methods we will show today, they can be run on paper too.
And then this one is on, she says, this is Karina, is it recommended that a lexicon be developed first and then tested on consumers using CATA?
Yeah, it's a good question. As I said, it can come from different origins, your lexicon, but definitely you should always pilot check, like all pilot test, all your consumer tests. So it's definitely a good idea to generate a CATA list of terms and check it with a few number of consumers, and then you can be sure that they understand the terms and so on. So in CATA, of course, it's the most important is the list of terms, because if you leave outside some terms that are key, then you don't get the information you want. So it's very important, definitely, to develop a lexicon that can be tested with a few consumers and then run maybe a larger consumer test. Yeah, no other question from CATA. I will go one slide before, just in case you missed part of what I was saying on the flash profiling when I got kicked out. So I was saying that flash profiling is run in 2 steps. First, the development of the attribute is done there, then and there by the consumers or non-trained panelists. And then they run a comparative evaluation on each of the attributes. So we give the sample set, they compare all the samples and they write their attributes. And then for each of the attributes, they will perform a ranking on each of the attributes where ties are allowed. So you see there, for example, this yogurt, this person ranked them from sweet flavor, from low to high. And he found that C was the lowest, A was the highest in sweetness, but D and E were similar, so he tied them together. So he should do the same for the rest of his attributes: acidity, strawberry flavor, astringency, and so on. So it's a bit long, a flash profiling, because the assessor needs to take all the samples to come up with the attributes and then compare them again for ranking them. So then you have here some example of ballot. Here, this guy Pete that we had before was assessing sweetness, graininess, fruity. And these are not scales, but this is just a direction. C is the lowest, A is the highest. You can use something like this also where you only have boxes, so they just write the letter or the number of the sample. This also can be run in some data collection software, in this case more specialized for sensory science, not so much in Google Forms and so on. But also it's possible to run it on paper, as in the examples you have here. And how you compute the data, this is ranking data. So you need to compute the rank, and then you can use the sum of the ranks to check that you have inputted the right data. So for example, for the sweet flavor attribute, from low to high, then you have 6 samples in this case. So the ranks will be from 1, that is the lowest, to 6, that is the highest. In this case, as samples D and E are sharing the position, then they will share the position 4.5. So it's like they are sharing positions number 4 and 5. So you input 4.5 for each of them. And a good way of checking is that 1 plus 2 plus 3 plus 4 plus 5 plus 6 is 21. And that needs to be the case for each of the attributes. So at the end, you will have a matrix like this one, where you have all the samples here, the 6 samples. And for consumer 1, pit, you have sweet flavor, grainy, and so on. And this is the sweet flavor that we computed here. We write the values here. So we will have a very long table that I like to call them a chorizo table, because they are long, like or a salami table, because they are very long and thin. And so you can fulfill that table on Excel, for example, and then a way of analyzing it, for example, using GPA, generalized procrustes analysis, that is similar to PCA that you saw with Ingun in a previous class, but the good thing of GPA is that it allows you to analyze data with different numbers of attributes in this case, because each consumer has generated their own attributes. So then they will have different numbers of attributes and different names of the attributes. So this is an example on a paper where we apply different rapid methods using for chicken nuggets. So I don't expect that you look at this because it's very small type, but I will explain. So in this case, there were fish nuggets, 9 samples, 10 semi-trained assessors, in this case, not consumer, in one session. So then there were these 9 samples of fish nuggets that were cooked by different methods, like oven, fried, or microwave, and they were either breaded or buttered. So you have the samples here, and these are all the attributes that were generated by all the individual consumers. So how can we interpret this? Is, for example, here we have many different attributes that refer to the butter, like butter thickness, butter adhesion, surface homogeneity, butter thickness, butter layer thickness, butter thickness. So then many, in this area here, we have the samples with a thicker layer of butter. So in fact, yes, these are the buttered samples here. Here we have attributes related to color. Here, all the consumers were referring to crunchiness or crispness. So we know in this side of the map, there will be the samples that are crispier or crunchier. So we need to interpret all the attributes together, which of course takes a bit of time of interpretation. And if you look at how in this paper it was looked in the correlation with of this flash profiling with untrained assessors or semi-trained assessors as compared with a trained panel via QDA. And we see the correlation is quite high. And when we see the two maps, they are very similar. So there is a very good correlation with the trained panel. And if you see a bit of literature, you will see that for all these rapid or alternative methods, you can find many, many publications that demonstrate that the outcome is very similar to what you obtain in big lines with a trained panel. As I said, the only a bit more complex thing in flash profiling is the interpretation, because you will have different cases of, like, for example, in this map where you have all the attributes, you will have that one judge assess bitter towards that side, while other one towards this side. And it could be difficult to interpret, okay, where lies the bitterness, what are the products that are more bitter. And also it could be a question of interpretation of the language. So for example, here we have that judge 4 assessed an attribute called fatty, and judge 3 smooth, and they are highly correlated. So probably they are referring to the same thing, or sour and tang. So it needs interpretation by the this is another example where we compare different techniques in some coffee products, so we're coffee with milk type of cappuccino. And in this case, we use flash profiling with British and French consumers. And via flash profiling, we obtained maps that are highly similar, and each of the consumers use their own language. So in this case, it was for a company that it's a multinational company working with coffee products, and it was very interesting to have a method that one could use with consumers, that they could generate their own vocabulary, and that what we obtained was very similar. In this case, consumers evaluated 7 samples, and one of them was repeated, that is sample 3, and you see here P3 and the repetition of P3, and here P3 and the repetition of P3. So consumers are very consistent. This method is quite repeatable. And in this map shows for the same data, the data dispersion from different consumers. And you can see different products are in different colors, and these dots are the consumers, how they assess the products. And for example, P1 is the blue dots. You can see all the consumers are close together, or P2 is here, the green dots. So you can see that there is a good consensus among consumers. So what are the applications of flash profiling? As I mentioned, flash profiling is a bit more saturating because all the retasting, but it's very good applicable for sensory description of products using a semi-trained panel. For example, a group of product developers. So if you have in the company or in the research group, a group of people that know well the products, but they are not trained as a QDA panel, flash profiling is very nicely utilized because they normally share the same language to describe the products, and then it will be quite easy to interpret the results. Also, it can be used with trained panels when they have no training in scaling the new product category, because for them it's very easy to develop the vocabulary and assess the products. But with consumers, even if it's a quite tiring method, it could be good for the example like I gave comparing France and UK, where we want vocabulary development by consumers, or for cross-cultural comparisons with different languages or cultures, and we want a product description by consumers. So any question on flash profiling before we move on to projective mapping? So these were the two methods I wanted to show you based on attributes, CATA and flash profiling. We will look now at projective mapping, also known as mapping in some of the literature, and you tested it earlier today, and you use the same interface that in this picture there, that is someone making a projective mapping at So I don't see any questions in the chat at the moment. Okay, so projective mapping, you have tried it. It's usually made on 2 steps. First step is the mapping itself, where similar products are placed close, and different products are placed far from each other on a surface. So you can do it on a table, you can do it on paper, using, for example, an A3 sheet of paper, and you just can ask people to taste and to place them on the on this sheet of paper. It can also be done in a data collection system like the one you use, but it's very well also done on paper. And then you add the words to the different groups or the individual samples, what is usually known also as ultra flash profiling. So we can do everything on a session of approximately maximum 40 minutes if you are tasting too many samples. So you will be doing something like this, where you can group and describe samples grouped together or individual samples. And how you assess the data. So for each of the maps that each consumer will make, one can measure where each sample is located. So we'll be measuring coordinates of where the products are. So for example, product 2, we can measure X and Y using this as an origin of the measurement, and we measure all the samples. I see a question also. Please clarify on whether all this data are analyzed using the consumer check. No, sadly, no. None of these methods we are seeing today can be analyzed with consumer check. So you can you need to use, for example, Excel stat if you have it, or free software like R. But consumer check is not able to analyze this type of data at the moment. So once we measure this on each sheet, we can put together our matrix of data for analyzing it. So you see here product 2 by consumer 1 has an Y, an X and a Y. So I measure all the product 2 for all consumers and will be like this. And for each consumer, all the coordinates of all the products. So we will have a very long, very big table that will be all the consumers. And here in the rows are the products. And there will be a second table that it will be the attributes that they have used. In this case, what we will do will be counting the number of times that each attribute was repeated for that sample. So for example, we see that product 2 was described as bitter and watery, and we know that this consumer and 20 more, so 21 consumers mentioned the word bitter for product 2. So this will be, this means that researcher needs to be quite a lot of work with the interpretation of these words. As I showed you when I showed you your data from today from the projective mapping, the data collection softwares also have this automatization on how to analyze this type of words, but it's very rough, so this needs interpretation by researchers. Oh, I just realized that I left these maps in Norwegian. Sorry about that, but it doesn't really matter too much in this case. It's the comparison of a projective mapping done by consumers and by trained assessors. This was some different samples of apple juice. And one can see that the maps were very similar. So these are the samples 7, A and B, that they are symmetric, but they are here and here. Then samples 2, 3, and 5 were grouped here, and in this map here, sample 6 separated from the rest, and sample 1 and 4. And they were described. And how we interpret is the same way that we interpret PCA plots. So samples that are laying on this side of the map are described by these attributes. Samples that are on this side are described by these attributes. And projective mapping data is usually analyzed by multiple factor analysis. Multiple factor analysis is, in fact, a series of PCAs. So it will be run some PCAs on the individual maps and then put all together in a consensus map. And this is all, again, done by specialized software like Excel stat or like R. As mentioned before, this is something that we can maybe follow up in a more detailed course when we go more in depth into rapid methods and their data analysis. It won't be a topic of today. And well, this is just an example of individual configurations of these also wine samples when we can see that this assessor here separated sample 6 very much, while the other assessors put them more towards the middle. So the maps could be completely different because assessors will use their own interpretation or their own parameters that will take the samples farther away or closer together. This is an example that was one of my PhD students some years ago, that she was working on products that were enriched with fiber and low in sugar, low in fat. So she used these Maria type of biscuits that are very popular in Spain as an object of the study. And she used projective mapping in different scenarios to get information about this category of products. So first of all, she ran a projective mapping just on the pack, like the one you ran today, you perform today on the potato chips. But in this case, this was run on, I think there were around 30 samples or 40 samples of different biscuits that were on the Spanish market. This was done on a big table, so consumers had all the boxes and they could look at them and they will map them on a table. And then Elizabeth was measuring all the coordinates after each consumer. Then we have another session where consumers got just the nutritional info of all these packs. So cards that look exactly the same, so they were not biased by the design. They only get nutritional info and any claim that could be on the pack. In a third session, they tasted some of those samples. So from these two maps, we took 10 samples that were very different from each other, and they tasted them in blind, not getting any information. And a fourth projective mapping was run tasting plus these nutritional cards. There is a paper on this that you can read with a lot of information, but just some interesting facts. So these are the descriptions, so the words that consumers used and the frequency that they were utilized. So it's interesting to see that, for example, in session 1, they didn't taste the samples, but many sensory descriptors were used. Like today, when you looked at the crisp, you already have expectations about the taste, even if you haven't tasted them. It could be that some consumers have tasted some samples, but definitely not all the samples. And in session 2, that is nutritional cards, they were a lot of course, attributes regarding nutritional health, but also some sensory, and even not having any picture. Also in the blind tasting, that is session 3, you see that mainly it was a big number of sensory attributes, but consumers also came up with nutrition and health characteristics, even if they didn't have any information about the product. So projective mapping could be a very good method to get completely undirected information about consumers. In this case, about a category of products. If you want to have very undirected information about consumer perception. So what are the applications of projective mapping? Sensory description of products by non or semi-trained panels. It could be, as we said, as we just saw, for consumers, but also it can be a group of product developers. We can also use it with trained panels when they are not trained on a category. And we can also use it with trained panels or semi-trained panels when we want to screen down a big sample set previous to other tests like QDA. Also, it can help for vocabulary development by consumers, cross-cultural comparisons, again, because we don't ask anything from consumers. Also for market exploration of a category of products with consumers. And it's very interesting because it focuses more on a holistic perception. It's not attribute-based, but we only ask consumers to map products depending on similarities and differences. And I think this is the last technique I will show you that is quite new. I see that there is a question before that. I have a good experience on data analysis in the last week lesson. This is my gap. Is there a possibility to have the software like panel check and consumer check for today's lesson? As I said before, panel check and consumer check cannot be applied to analyze this data. This data is analyzed using specific software for sensory analysis, like Excel Stat, for example, but otherwise using R, that is this free software. And as I said, this could be the topic of a next course. Is not planned for the first training school, but we can definitely discuss, for example, during later in the year or next year to have a course on rapid methods. I will discuss it with Riet and others in the project. Okay, so the last method we will go through today is polarized sensory positioning. It's one of the newest one developed, and it's been developed. It was developed originally to taste water, so mineral waters, because it's very much applicable when we have samples that are very similar from a sensory perspective. So what we do is to compare the sample we want to evaluate against 3 references. So then we will taste the sample under evaluation, taste the references, and rate if the sample is exactly the same or totally different than the reference. And we'll have a strike on the scale. This is an example of the type of data we obtain. We have each sample and the difference to the reference. This data can be analyzed, for example, with multidimensional scaling, but this is the only one that could be, in fact, analyzed in panel check, because we can use PCA for this type of data. So we said that we need 3 references that are also called poles, and that's why this is called polarized sensory positioning. So how to choose those poles? They need to be different enough, so we can do, for example, we can use previous data we have from the products, or we can do a pre-tasting. And the idea is that the 3 references we use, they stretch the sensory space under evaluation. So then we can compare all the samples to that. So what are the applications of polarized sensory positioning? We can use it with a trained panel when they don't have training in a product or a category. When we want to compare products that are very close in characteristics, as I was saying, waters, different mineral waters, and this is easier by the use of references, because it's always a comparative evaluation. Consumers can also perform PSP, and you will find in the literature. However, we need always to consider other simpler options, because PSP is quite saturating, because every sample you need to compare to 3 references. So that will depend on the objective of the tests. So we go to conclusions and recommendations. The most frequent applications of rapid methods when we don't have a trained panel in the institution for that product, when we need a quick response, for preliminary studies of a category or a market, like the example I showed on the biscuits, to develop vocabulary from the consumer, for cross-cultural studies, for example, projective mapping or flash profiling, when we don't need language, when a holistic perception is needed, for example, projective mapping, or to obtain direct input from consumers. Something I didn't mention in the specific techniques, but the recommended minimum of subjects, if we are working with consumer, is around 50, just if we want to obtain a map with a description. And if we are also gathering liking data, recommended number of consumers is 100. All of these techniques can be, the data can be collected in a software for data collection, but all of them can also be done on paper, as I mentioned. In conclusion, these new alternative methods are quick, valid, and reliable tools to characterize foods, pack, concepts, etc. We have seen various examples that are similar to QDA in AdCam, but they are not a substitute for classical tools as QDA, but they are complementary. They show similar results. For example, if we obtain a similar map, but QDA will always give us more detailed data with regards, for example, of rating of intensity of different products that we don't obtain with these methods. And if we combine them with liking, it could be a very good tool for preference mapping and ideal product exploration, like the examples we saw for CATA. We can also use this ideal product exploration with other methods like projective mapping. So sadly, I need to leave to another meeting, and with these multiple cuts, we don't have a lot of time for questions, but I will be very happy if you send me questions through email, and I will also share the slides with you as in every lesson, and hopefully the recording will be there. I'm hesitating because of these cuts in Teams if the recording has been actually recorded. Hopefully it was, but please send me any question you may have via email. You have my email in all the slides I have shared with you. Sorry again for the multiple cuts in Teams, and see you in the next lecture. I wish a good day for all of you, and see you soon. I think I still have one lecture with you, and definitely I will discuss with Riet and others in the InnoFoodAfrica project the possibility of having a specific course in rapid methods later in the project. I see this question in R PCA. You can use different softwares. I think within GUN you also utilized the panel check in the last sessions. ECA can be run in panel check and in consumer check also. Thanks everyone. Bye bye.
Bye. Thank you.